Hello guys, welcome to another video about Azure Databricks and EventHub. Today's video would be something like the continuation of our previous video about Azure EventHub and Databricks. If you haven't watched the previous video, please watch it as it will be necessary if you want to follow this example. In our last video, we sent data into Azure EventHub from our local PC and saved the data in Hive in Delta format. This time we're going to save the data into a data lake and create external tables in Hive pointing to the data lake. And everything will be in real time. Bear in mind, this is a simple example. It does not reflect a complex data pipeline, but it does serve as a starting point if you want to build a data lake with streaming data pipelines. We are going to follow the medallion architecture, which is the recommended architecture by Microsoft and Databricks. First of all, let's check our architecture to understand what we are trying to achieve. Okay, so here is our architecture. Remember, the first step is to send data from our local PC in Python. EventHub receives those data, and then using streaming pipelines in Databricks using PySpark, we append the data on the bronze layer in Delta format. The data on the bronze layer are exactly as we received them from EventHubs. Then we are using PySpark again to perform some aggregations and merge the data on the silver layer. And finally, using again PySpark, we are performing a few joins, and we merge the data on the gold layer. This is the final version of our data, and from the gold layer, the client can get. This is where we can start building reports for the clients, etc., etc. So on the gold layer, we have the final version of our data, the cleansed data, aggregated data, after performing joins, etc., etc. This is the Python code that we use to send data to Azure EventHub. You can find the code on Azure documentation. Just copy paste the code from the documentation into your VS Code. The only thing I changed here is to create a dictionary with multiple fields. Let's pretend that we have an IoT device producing data. Let's say we have a device ID, an RPM, angle, humidity, wind speed, temperature, device timestamp, and device date. And we send this data into Azure EventHub every few seconds. Respectively, on Azure, we have a storage account where we are going to create our data lake. I have already created a container here called IoT. It's empty, as you can see, and here is where we are going to build our bronze layer, silver layer, gold layer using PySpark and Databricks. This is our Databricks notebook where we have the PySpark code that creates the data lake. Apparently, the first thing we need to do is to receive data from EventHubs and stream the data to the bronze layer. We need to get the connection string from EventHubs. You can find the connection string in your go to your EventHubs namespace, scroll down to entities, create an EventHubs instance here, click on add EventHub. I have already done it, and then click on your EventHubs instance, and under settings you will find the shared access policies. Create a new policy, click on your policy, and then copy the connection string primary key and paste it here in your connection string in Databricks. Then we have to provide the consumer group. For me, it's the default consumer group, and the JSON schema, which represents the schema of the data that we are receiving from EventHubs. Let me run this bit here. Perfect. The next thing we need to do is set up access to the storage account. Now you have to define the storage account, and here for use spark.config.set, and you need to use your account key. So go back into your storage account, and under access keys, actually under security and networking, click on access keys, and you will find the access keys here. You can rotate the key, update the key. But here, just copy that and paste it here. So this is just a way to get access to our storage account. Then we define the storage locations for all the data. So we have the root path that point to the IoT container. So let's go to our container. We have this IoT container, and the bronze path contains, it's the root path plus bronze. So this will be the path for the bronze layer. Then we have the silver path for the silver layer, the gold path for the gold layer, and the checkpoint path where we are going to store our checkpoints and the state of the data. Here we have a few Spark configurations to make it to make our code more efficient. So the first thing we need to do is actually use an optimize write property and set it to true, and then auto compact property here, set it to true as well. Now, if you go into in the documentation, you will see it says what is auto-optimize on Databricks. The term auto-optimize is sometimes used to describe functionality controlled by the settings, delta auto-optimize, auto-compact, and delta auto-optimize, optimize write. What does that mean? Auto-compaction for Delta Lake on Databricks. Auto-compaction combines small files within Delta table partitions to automatically reduce small file problems. Auto-compaction occurs after a write to a table has succeeded and runs synchronously on the cluster. And then you also have the optimized writes property here, which says optimized writes improve file size as data is written and benefit subsequent reads on the table. So if you want to increase your performance and optimize writes and make files smaller, combines. If you want to optimize your code, you can enable those Spark properties. I have disabled the format check. It's not necessary right now for this example. The next thing we need to do is drop the Hive tables if they already exist. So let me run this command. And now if those tables exist in the Hive database, they are going to be dropped. Perfect. And now it's time to start streaming data, right? So let me run this. And as you can see, we are using spark.stream.format event hubs, all the configuration that we have in that dictionary. And we are performing a few transformations here because we need to get the body of the data. And we select the columns that we want. I went through this in our previous video, remember that. So let me send some data from our local machine. Let me run the Python script, and we should start seeing streaming data in real time, right? Perfect. Yeah, the data is coming in. That's what we want. And this is how we are streaming data. Now, the next thing we need to do is actually create the bronze layer. We are going to divide the data into two different entities. Remember, this is just an example. It doesn't really make any sense to split the data right now, but using that as an example, we are going to split the data into two entities. One would be delta table 1 row, and one would be delta table 2 row, right? And for the first table, we are selecting device ID, RPM, angle, device timestamp, and device date. Of course, we are saving the data in delta format, and we partition the data by device date. We have to provide the checkpoint location, and we can start streaming the data to the bronze path plus the delta table name, right? The same for the second entity. But here we select humidity, device ID, humidity, wind speed, temperature, device timestamp, and device date. Let me run this code here, and as you can see, we are starting to stream data from the data that we receive from EventHubs here into our bronze layer. So let's see, let's send another batch of data from our Python script and see what we get. Let's see here, we should get more data right now. We are streaming data here again. As you can see, the Spark jobs are being loaded. And if we go back into our data lake on our IoT container, you would see two folders, the bronze folder and the checkpoints folder. On the bronze folder, we should have two tables, one delta table row, and it should contain data here partitioned by device date, and you will see the data here. And the same we should have for table 2, yeah, right? You can see table 2 here, and also the checkpoints location where we save the state of the data. Perfect. Now let's create our external table. So using Spark SQL, we write create table if not exists, delta table one row using delta location, and that we point into our data lake. So we are going to create external tables pointing to the data lake. Let's run this command. Perfect. So in theory, under data now, we should be able to see two tables here, right? Perfect. Let's go back into our notebook. Now that we have created the external tables, yep, here we are. We can actually perform an SQL query to select the data from the Hive table. And here you just use SQL, straight SQL, and you query the Hive table, the delta table row, and you will see the data here, right? And this is how you create the bronze layer and external tables in Hive Metastore pointing to the bronze layer. But you don't need to query the data lake, but because you can query the Hive tables and perform whatever transformations here that you want and check the data. Then the next thing is actually to create the server layer. So the server layer is a bit more tricky. We are going to aggregate the data based on a 30 minutes window, given the device timestamp column. So let's say we have already created the Hive tables for the bronze layer. Then we can start reading data from the bronze layer, streaming data from the bronze layer, and we can group by the data, create aggregates based on 30 minutes intervals, right? And get the average of RPM or angle or whatever. And then write this stream on the server to the server layer. And we can do that by using the for each batch functionality, right? So if you go into the documentation, you will see what we have for each batch allows you to specify a function that is executed on the output data of every micro batch of the streaming query. It takes two parameters, a data frame or a data set that has the output data of a micro batch and the unique ID of the micro batch. So if you go to the documentation again, you will see in the Databricks documentation this time, you will see that they provide already an absurd delta function here that uses a for each batch. So here, what it does is actually define a function and create a temporary view, and using this temporary view and SQL, it performs a merge operation and writes the data into the data lake. And here you can use this code, here. I used this code to actually create this merge delta function that I have here. It's exactly the same thing. I have added the try and except, and here, if the table does not exist, then create a new table in the data lake partitioned by a device date. And here we pass the data frame and the destination. Target is the destination. And if let me run this command here. So now we have the merge delta function. And here for each batch, we use lambda, the anonymous function. We pass two parameters. We call the merge delta function. We pass, the micro batches of the data frame and the target and destination, which is the silver path plus silver path table one, right? And output mode is update. So as you can see in the documentation, here we are. I think it says, yeah, this is much more efficient than complete mode. As you can see in the documentation, they have this part here for upsert from streaming queries using for each batch. You can use a combination of merge and for each batch to write complex upserts from a streaming query into delta tables. And this is where it says, the update mode is the most efficient mode that you can use for streaming aggregates. Okay, back to our notebook. Let me run this command here. And the same for, we have another table called serial table 2. We are performing the merge on both. We are performing the aggregations based on the 30 minutes time window on both entities that we created on the bronze layer. So let me send some data from our Python script. And hopefully in a minute or two, we should see the data into our silver layer. Let's see. Yeah, as you can see, I think it picked up something. So if we go back into our container, click on refresh, we should be able to see the silver layer and two different entities, silver table 1 and silver table 2. And we have the data now. As you can see, we have the aggregated data. And that's the second entity. We have data here as well. Perfect. Splendid. This is how it works. And everything is going all right now. Perfect. Let's create two external tables, Hive tables pointing to the silver layer. And let's perform, let's say, a query. This is how you can perform a query on your Hive tables. As you can see, it's a pretty normal query from silver table 1 and silver table 2, the Hive tables on device ID ordered by temperature. So you can perform whatever queries you want on every layer, which is perfect, right? You can check the data, debug, and all this kind of stuff. Okay, so time for the last part where we create a gold layer. The first thing is to stream the data from the Hive table that we created for the silver layer. As you can see, it's the same except for this option here. And if we go into the documentation, it says structure streaming does not handle input that is not append and throws an exception if any modifications occur on the table being used as a source. So there are two main strategies here, and we can use the ignore changes. And it says with ignore changes enabled, rewritten data files in the source table are re-emitted after a data changing operations such as an update, merge into, delete, or overwrite. So bear this in mind. And here, so if you don't use this option, it will throw an error. And then we join both those tables based on device ID, and we select the columns that we want, which is basically device ID and device date and all the averages. And it's time to create the entity on the gold layer. Again, we get the enriched table here, and we use write stream for each batch. We use the merge delta function that we created above. We pass the checkpoint location, output mode is append, and then we start streaming the data. So let me run this command. So we started streaming the data on the gold layer. Let me send another batch from our local PC, and we should see the data on the gold layer, all those transformations here. Let's see, it is streaming the data. Give it a second. If we go now into our data lake, click on refresh, we should be able to see the gold layer. So click on the gold layer. We have a gold table. Now it will take, here it will take just a few seconds to load the first data. You can see the data here. And the next thing we can do is to create an external table again, pointing to the gold layer of the data lake, and then we can start, selecting data from this Hive table and performing whatever changes we want. As you can see, this is the data. Databricks also provides visualizations. As you can see here, we can create a visual add column. So let's add, the average humidity and create all those cool charts here. You can click on save and you can see the visualization here. You can also use the data profile. You can see here, the data types, the mean, the median, the max, whatever you want to see here. It provides cool details about the data, and you also have the visualizations and of course the data itself. This is it, guys. This is how you can create a data lake with PySpark streaming pipelines within a few minutes. I believe it's amazing that you can build data lakes in real time with just a few steps. Obviously, that was a very simple data pipeline. However, it gives you a good idea of how to start building your streaming pipelines and the data lake from scratch. This is the example I followed. I will provide a link in the description. Databricks documentation provides practical examples which are very insightful. If you find this video helpful, click the like button, add a comment, and subscribe to the channel. Thank you.